Happy Wednesday. Happy June, by the way. We've
Oh, yeah.
officially, right? Isn't it
Yeah.
summer or is that last week, Labor Day? Anyway, we're in the throes of
Yeah.
summertime. Always
Yeah.
good. I like summer.
Yeah. Yeah.
You
Me
all
too.
in
Yeah.
full bloom?
Yeah. 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 We are kind of getting closer to the enormous IPOs that will change the world, and we will see, like birth of multi-trillion dollar companies.
Very interesting point of view. I'm not sure if it's ancillary, but I don't think it is because everything's so strangely connected. But it's SpaceX. It's
Mm.
apparently valued at trillions or something. And because it's so
Mm.
huge, everyone in index funds has to buy it. So it's also reinforcing a valuation, I guess. But then Morningstar
Yeah.
came out today and basically said it's worth about half as much as they think it is.
Mm.
Which in itself is funny because it's like, okay, I don't know. I mean, this back in the day, the Winklevosses, I guess, gave what's his name some cash, right? And then that turned into an entire legal system got created on its own just to deal with some guy
Yeah.
who invented a funny app, but
Yeah, yeah, it's very difficult to evaluate the value of a Dyson swarm, right? Like if they're gonna send the compute, to the orbit, right, and create this Dyson kind of like a network of satellites that will be powered by the solar panels. So basically free energy, quote unquote, right? And then they don't have to be cooled because they can radiate the heat to the universe, basically. So that is an attractive proposition. And if and there is a proof, right? They were able to create the Starlink network. So there is not a huge difference between the two. So yeah, how do you evaluate that? And on top, the moon base, and on top of the other things, the all the stuff that they are doing for the military potentially, and then the travel, like half an hour, travel time to any point on the planet. So all these things are kind of crazy, individual, and then taken together. Yeah.
I think what a good summary because I don't know if this is always ancillary, but ever since we got into our world, right, our world of Bayesian updating and Markovian, multidimensional thought, right? Now that we're in this world, I turn to try to study physics, and I have learned in some ways people are like, well, that's what people usually tend to do when the real world gets way too complicated. Try to study physics because you'd at least think it's simpler, right?
Mm.
Um, but I had a great time watching all the Feynman lectures because Feynman's kind of funny. But what
Mm.
one thing that struck me, maybe to this point, is certainly behaviorally. I know that and I'm teaching it right now, but we have that system one, system two thing that we talk about a lot. But people love to be linear, right?
Mm.
Everyone loves linearity. And the thing is, the very foundational problem of physics was that, hey, you put light through something, and if you ever try to look at what it's actually doing, it'll behave differently than if you don't look at it. And it bugged people pretty much forever until now, which to me, I'm like, well, the thing that we don't study is interference. When things don't happen, they're sometimes just as interesting and foundational as when they do happen. So I think it's interesting that, as we go on into the infinities of whatever this space company can do or whatever, it always is about linearity. Hey, and why shouldn't it be? Because we invented these computers that we control time, right? Like computers wouldn't work at all if they didn't have clocks that were absolutely 100% not like real time. Real time is weird. Let's just point that out, right? Real time
Mm.
is it's very interference oriented, let's put it that way. It never will kind of act the way you want it to, which is good, or we wouldn't have a universe, I would say, right? Like, none of this would
Yeah.
happen. But whenever we get into these control situations, I think isn't that always the fiction, right? It's like, beware because interference is going to happen, right? Like you just can't ever predict. And maybe I can ask you this question because I really don't understand it. Like I know we're doing build outs of whatever they call data centers, which are controversial
Hmm.
in anticipation of something. See, what I'm thinking is the reality is I don't know, you and I can both use a model which is beyond anyone's even belief 2 years ago, right? Like, and it's pretty much instantaneous, weirdly, right? Like, and really good, like whatever, right? These new models, I guess they come out with one every so often, and they're like, hey, this is the much better model. And I'm teaching my students with RAG because I'm like, at least you know kind of what the two inputs are, right? You don't know everything else, but at least you have a little understanding, more so than if I just gave a model some problem and had it come back with
Hmm.
some solution. So I don't know. Am I making any sense? I'm like, well, these things already seem great. What are you building these data centers for? The future when what what is needed actually that we don't have right now?
Well, yeah, yeah. I mean, there is a few bets, that are kind of like going in one way, and then there is a few bets that are going the other way. I think the bet for the increased compute is that there is this probably anticipation that the size, the brute force, necessary to get to the super intelligence that is going to solve, fusion, that is going to solve, chemistry, biology, that is going to kind of like solve research problems, make us immortal, that kind of stuff, right? That's kind of like a subject of the discussion. Like OpenAI is very, it's not a big secret that basically they are their direction is to have like a deep research systems, right? That can do research, right? Like scientific research, right? So the anticipation is that we're gonna need a lot of more brute force to run that stuff, right? So that's kind of one direction, and
So
then
sorry,
maybe yeah,
linear thinking, correct?
exponential, yeah. So they are thinking exponentially, right? So they are thinking, hey, we are in the singularity, which means that the singularity concept was that okay, so if we are linear, right, then yesterday the model was like 10x, and tomorrow it's going to be 20x, right? That's a linear kind of like progression. What they are thinking is that we want to get into the super intelligence, which is going to be on the exponential path, like which is going up, right? So today 10x, tomorrow is x to the power of 10, right? So that's kind of the
So can I just
anticipation.
pause while I
Yeah.
sell all my stocks right now? Because guess what happens when you try to predict linearity, right? Is it always collapses because interference. Am I wrong about this? Wait, have we not learned any lessons, I guess?
Yeah, you
So here,
quoted, yeah, you quoted Morningstar, and I'm pretty sure at the bottom of the website it says that past performance that does not
does
guarantee
not
future.
indicate future returns. You're right. No, actually, it's so funny because my father got trapped into this one of these schemes, a long time ago. I've been trying to extricate because he put all his retirement savings into this idea that you can't lose, right? Always a
Mm,
great idea. Like you can't lose in this technique where
mm,
you buy a stock and you sell a call and blah 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 blah. And he explained all this to me, and he said all you have to do is extrapolate this gain you made this month times 12 and look at how
mm,
much money you've made. Well, apparently this line works all of the time, right? Like taking something and just multiplying it by 12
yeah.
answers all questions. And I'm like, but you can never multiply it by 12. Like this just sort of happened.
Yeah, unless your name is Gordon Gecko, right? Gordon Gecko probably can live by that rule.
Actually, the guy, there is a actually really clever guy. We should study him because he did model the stock market. He didn't model it. He modeled it as a series of relationships, apparently. And he just said that this relationship is kind of like these blobs that are correlated. So when one blob gets smaller, another blob gets bigger, and it's sort of basically organic looking. and I think it's called Renaissance Technologies. Anyway, he made a fucking fortune off of this idea because it's true. Like that to me is more of like a systems understanding. Like they're going to be relationships, but those relationships are not linear, right? They're clustery, I guess is the point, right? Like I bet there's probably certain bits of an LLM that get a lot of work. And there's probably lots of bits of it that don't do shit. You know, but since we don't know what it does, right? We weeding it out is probably what you say is just a isn't this back in the day when you wanted a 60 frame rate? You know, that's all you wanted in life was, 60 frames per second. You're like, if I only had 60 frames per second, man, life would be good. But of course,
Well, yeah, that's another part of the bet, right? Like the video models, the multimedia models, that will be a rapid increase in compute. So
that's true.
but then there is the other direction, right? So there's a competing bet that the models will get more and more economical to your point, right? Like, hey, we're gonna figure out, what is really needed. So then there is the, 1 bit models that we can run locally on our laptops,
Yeah.
and they are not going to be, obviously great. But if you can be clever about how to orchestrate things, maybe you can get close, to maybe a frontier model, right? So perhaps, yeah, maybe the bet, in the compute brute forcing is maybe kind of like at the end of the day is going to turn out to be completely not necessary.
Yeah. Well, and it always does. This is the point. Like we always multiply by 12 because that's the story that sells. That's all, right?
Mm.
I mean, if you're going to give whatever $1 trillion to SpaceX, it's because you have some crazy idea that X, Y, and Z is interesting or useful, right?
Mm.
Um, I mean, personally, I don't know, this may be a tangent, but I'm really impressed by 5G internet. Sorry. I mean, it's weird that we had to cover the entire land with telephone wires, right? Like that was absolutely an insanely expensive and continued to be a maintenance issue. Everything about it is extremely expensive, but we did it
Mm.
and we all
Yeah.
paid for it, you know?
Yeah. And what I'm worried about is that, knowing that, for example, the cancer rates for people who work on wires, are very high,
Oh, yeah, electricity
seeing,
sucks. Sure.
yeah, seeing those antennas, on every corner, basically in the city, kind of makes me a little bit worried that there is kilowatts of that radiation being pumped out. And, the people who have to work on this are completely screwed. And chances are that maybe we are screwed as well because there is more and more energy in those electromagnetic waves that goes through us, every day. And then, you know,
Well,
I'm not
ionizing,
sure.
non-ionizing usually. Yeah, it's a thing, right? Like
Mm.
it's when it can actually hit one of your molecules and make it unhappy. So
Yeah.
who, there, but remember, poor Feynman was in there milling plutonium for a long time, and he seemed to survive. So I don't know. Maybe it's
Yeah.
all luck of the draw after some.
Yeah. But the guys that were running the first reactor in the basement of the
Oh,
University of
Mary
Chicago,
Curie died
they
pretty
were
quickly.
yeah, they were not that lucky, but they didn't know what they got, right? So then there was the famous story about the devil's core, right? Like, there was, so they put together that plutonium core, and if you kind of clad it in a wrong way, then you kind of begin to amplify the reaction, and suddenly, there is a, very, very little dose, kind of within a second, So yeah, those are very real issues, that I know.
Well, I mean, right now the big debate, as far as I could tell, they're building this massive, massive thing. Building, meaning it's not doing anything yet, right? But they're building out this capability in Utah, and then they're complaining, of course, which is realistic about its water usage. I guess that's the thing. And all I could think was, didn't we used to do or still do that with fracking and coal? You know what I mean? Like we're constantly
Yeah.
messing with stuff.
Yeah, and who would want to have, like a, completely safe small modular reactor in their backyard? I mean, no country is gonna ever agree to that, right? So maybe Elon's got a point, like, hey, let's just send everything into space and be
Well,
done with
except
it.
don't you need to like unplug it and plug it back in again, as I had to do with my computer because it started to misbehave? Like,
Yeah, maybe.
it's trying to figure out like, okay, if you can't get to it easily. Wait, by the way, speaking of fun times, back in the 70s, remember when Apollo 13 happened, that we had all these movies about rescuing people in space? And that was like a big theme, which of course is completely not a thing you can do. Well, because that's the funny part, right? Like you're kind of saying like this is it. Like you got one shot and we're really clever, so don't be worried. And I'm like, okay, I don't know. I mean,
Well, maybe they're
fine.
gonna be running Linux on those data centers instead of Windows.
One can only hope. Well, one can
Yeah,
only
but
hope by then that AI has their own operating system, which, by the way, might be now that we have only a half hour left. I was trying to think of you know the not the irony, but the reality is the computers are incredibly fallible, and it's amazing they work at all. Right? Let's just put it that way. So that they work at all is dependent upon a ton of very not flimsy, but fairly flimsy constructs. I was saying the idea of a clock, but not a real clock, a perfect clock, is inherent to the entire system. And I was just looking at uh, amplifier schematics the other day. Somebody was just talking about like, hey, it was great. All we did is we took a wire and we kind of bent it a little bit, and then we stuffed it in a thing, and then we know exactly what this does, right? That's what electronics was. Like they were kind of big physical things, but underneath it all was just a principle of, hey, if we wrap a wire this way around this, it'll do this thing pretty reliably, right? And we've been working on that forever, and I'm still pretty impressed that somebody kind of inherently has a mental model that says, oh, right, you put a diode here and you put a resistor here, and then this will happen. And in fact, this was a explanation of power supplies. It's like, how do you get power that's not happy and kind of rough and smooth it out? And I'm like, well, that's, what an interesting thing to do, right? Because all of our devices do not like power that does weird stuff, which I'm assuming is sunlight, right? Like sunlight's not going to be whatever, here you are completely. No, sunlight's going to be weird and spiky and shitty, and then you need some sort of way to not make it do that because our devices do not like that. Am I making any sense? Like we kind of take for granted that we know how to do that, and we have for pretty 100 maybe or 70 years. Let's put it at 100, right? That we've been pretty good at knowing like, hey, physical manual work, we can relegate it by using leverage. So a lot of things are just like gears. Like, hey, we figured out like you don't need tons of power if you've got gears. So super clever, works every time. Am I with you? So now we just do that at smaller and smaller and smaller, levels. But now the complexity is so huge that I was looking at how they architected the M1 chip or something, and it's like it's still the same thing. It's just so small that it's kind of funny that, hey, this resistor, well, yeah, these are all in there, but there's a trillion of them, and then it just becomes I guess it becomes daunting as an educator because you kind of want our kids to understand, like, this is a house of cards in some ways, right? Like it all depends upon this linearity. But as I said, I don't know. That's a lot. You're probably smarter in mechanical engineering than I am.
That is a very, very good point that you are making. Maybe kind of like, if, for example, if you look at the amplifiers or maybe the Hammond organ, right? Everybody knows that the Hammond organ is really kind of like the extremely well sounding instrument, and all the electronic, kind of models of it, like the new Hammonds are just not the same. And then, so, and the same way, like maybe the amplifier that you are describing that was kind of put together from those non-microchip kind of types of components, they are kind of maybe sounding better than the modern stuff that we use today. So at some point when we kind of get smaller and smaller, and then the micro lithography kind of came into play and allows us to build the chips, then we kind of lost maybe something in that machinery that was really special and unique. And yeah, and here we are, right, with a nanometer, microchips being kind of like, on the drawing boards.
Well, the theme thematically that's been my theme is always noise. The thing is that as people, as human, that we only trust things that are noisy because we can see them as being real, and so that's why everyone now I think is into these featureless rooms, like that's this creepiness, right? Like things having no features or having very even lighting and all these things are so artificial that they give us unease,
Yeah.
and it's why people like records that I think they just make so much noise, but that noise in a sense is like a performance, it
Mhm.
creates something new every time you play it.
Mhm.
Whereas they say it's lifeless, this is just a waveform or something.
Mhm.
So, there's a lot of points of view. I think it's interesting from this point of view of why these data centers are coming around to deal with the increased need for AGI. And I think, well, tell me how things are going with you because I'm still in this world and I'm trying to get my students are finishing up this week, by the way, and they're not. I don't know. They are getting it. I think they're getting the fact that their role in using AI or LLMs or whatever is extremely critical, right? Like how you use it is the most important part. It's an instrument, it's like remember the old Monty Python joke? It's we're going to teach you to play the flute. And it's like, yeah, you just blow in one end and move your fingers up and down. It's like that's I think people's model of what LLMs are,
Mhm.
right?
Mhm.
Like they'll just do whatever you ask it to do. It's great, right? And yet it that's not true.
Well, yeah, I mean, I think the big thing that is kind of happening right now is that, people, the usage of LLMs and AI was kind of going in a kind of maybe this flute direction, like, hey, and everybody wanted to have the best flute possible, right? Like, hey, or the Stradivari violin, right? I'm gonna be a beginner, but I'm gonna have to use the Stradivari beginner. So there is the news from today, kind of like shows clearly that the problem, like Uber kind of blew, like hundreds of millions, like some crazy numbers on LLM usage, within the organization. So they are shutting down, basically employee access, or kind of gonna do some sort of reporting on it. Then Microsoft, the same thing. They are shutting down access to Claude because they are spending too much on perhaps, things like, to your point, like, hey, maybe I have a question, what's the weather today? I'm gonna send that question to the frontier model that is extremely expensive, right? So I think there is no, without question, there's something, yeah, right.
It's
There's
like I
something
only
going
do
on.
protein folding questions. Don't bother me with the weather.
Exactly, yeah. So the kind of like the economy of inference, right? And the maybe kind of paying more attention to how you formulate your context, how you formulate the question, and allocating that particular like cognitive load level to an appropriate compute within the LLM is probably the primary question nowadays. Um, and Because even the most kind of vibrant and successful organizations simply cannot swing the cost of running those expensive LLMs.
Well, I think there's so much there that's really actually fascinating to me because I of course spend all at least 3 or 4 of my quizzical moments a day with an LLM, right? I'm interested or curious or whatever, and I do something and I engage with an LLM, and I do it because it's free, basically, right? Like I don't care about the models, I don't care about anything. I'm usually just like, hey, physics question, crazy physics question plus how do you make bread question. You see what I mean? Like I don't really care. I don't discern too much. But I did have a great experience, which was that we, like you, maybe not, it's not your year, but we have our taxes redone every year, and then there's a whole thing where they make you pay more money. And just as usual, they want us to pay a lot more money, right? So we always go up like outrageous amounts. I don't know why. And I know for a fact of how to do it. You go online, I know how to solve this. And by the way, I could also ask an LLM, which I didn't really try. And the point I'm trying to make is like some problems like this are very rare. We don't need them solved every day. And I think in a work situation, that's more the norm, right? Like if you were doing something extremely repetitive, I don't know. I don't think, right? Like it's like being a person at a checkout counter. The whole point of being at the checkout counter is to be able to scale if there's a huge line or not fall asleep if nobody's buying it. You know what I mean? You have to deal with the variances. That's the job, not to be good at making money or anything.
Yeah.
So in this case, I could do this. I could get an LLM to help me. I could file this paperwork. In fact, there's a QR code like here, file your appeal here. But instead, I called our local government, and there's a person who works there to help people, and called them up late on a Friday before Memorial Day. So they were working late, which good for them. What a great, that was nice. Very nice. Not only helped us, but told us about all these things that I didn't know we could do. Plus found, comparables or whatever, filed the report for us. You know what I mean is like, I was really kind of like, wow, this ability of this person to A, have this job and B, accessible to a human like me, and also very good at something that I don't do very often. One could say this could be like, I've always done my taxes with TurboTax because whatever. It's like finding somebody who says, no, I'm going to do your taxes, but I'm going to make it so much more fun because I'm going to do all the work. And even better, this person doesn't charge. But you see what I mean? Like this ability to outsource that kind of skill, I am worried about. Because I actually do think that most jobs are this kind of job. Like the doing part is not hard, but the rest of the part is very difficult, right? The rapport, the relationship, the role, it's like having a good waiter. Like they don't do anything. They don't cook the food. But sometimes your experience is absolutely, transformed if you have somebody who is good at that job.
Yeah, that is a very good example. Basically that appeal, for property tax. I think at some point that will become an AI adversarial battle, where the government model in charge is going to be optimizing for increasing basically income from the property taxes. And then there might be adversarial models that will be kind of trying to kind of appeal, right, to your point, or maybe kind of like reduce the taxes or something like that. So it's going to be basically a cyber battle that is between those more and more kind of like capable entities that are optimizing for opposite objectives.
Well, I do absolutely understand that point of view, but let's just take our reality for a second, right? 2026. And I know you're in this as am I, right? So we're in some fairly sophisticated environments in academia. I think, like we're not behind the times, although I have worked also in massive companies, right? And right now, this need for generative AI, I am going to go out on a limb and say nobody is using it except for fitness tips. You see what I mean? Like, I don't think there is any widespread usage of generative AI, except maybe meeting notes. And even so, guess what? I was in a meeting with all of my whatevers, my fellow faculty, and they're like, "Oh, well, good. I'll send out the meeting notes." And guess who has not sent out the meeting notes? But it didn't matter because I was in the meeting. But you know how now meeting notes are easy, but now no one pays. We pay even less attention to them, is what I was getting at, because they didn't even bother to send them. You know what I mean? Even though there's no effort involved. Used to be my boss literally at the end of a meeting would write up the meeting note saying, "You're supposed to get this done and send it," in order to bug me to do my work. Right? Whereas normally we just ignore it. What I'm saying is that I don't think generative AI, in a sense, has a place yet. But I do think that ML does, right? I think that's the weird, the poster child is that, hey, we've got all this data. Let's have ML. Let's try to see some patterns that we couldn't see before. Because I was looking at SAP, which is being dumped, and looking at Oracle, which you'd think would know everything, but it doesn't, because it's not designed that way. Anyway, sorry. Now that's my own cynical opinion. Do you have a counter? Do you think?
Well, you have a very nuanced discussion here, right? Because you are touching on two kind of buckets of AI, right? One is the
Right.
maybe traditional machine learning, right?
Yes.
And the other one is the generative, right? So I think we need to unpack this a little bit, because there's a significant difference, right? So
huge, night and day. Yeah.
And then there is buckets, right? And buckets of innovation and buckets of usage where perhaps one is far greater than the other, in terms of traditional ML and transformer, LLM based machine learning. So what I'm seeing is that there is a bucket, for example, in coding, right? I think the usage is very heavy, right? So, and that has to be transformer LLM based architectures, because traditional machine learning was kind of there was conferences on how to use it. It was never moving forward, right? So I think there is a lot of value creation in new code that is being developed. And then there is also a lot of value creation in the refactoring of existing code bases, checking it out, documenting it, that nobody was ever doing. But now, now maybe a little bit more, because you have to still tell the LLM, hey, create documentation, right? And that's one sentence, maybe that's even too much, right? But still, you can do this. So that's one bucket. Right, then there's the kind of like middle of the road, like corporate, applications, right? And here it's probably you're absolutely right. I mean, beyond the documents summarization, meeting notes that are maybe useful or not that useful, unless you are really you have a dedicated agentic framework to kind of make them useful, right? Then that's really probably not worth spending, those trillions of dollars on tokens, right? And then there is, yeah.
No. I think I was agreeing. I really, I guess what I'm saying is, like us, in the realm of dealing with computers, I think absolutely generative AI is significant, right? However, application on an individual level is going to be haphazard, and that's why I think coders have also, by the way, affected my livelihood, or once livelihood, of being a designer, right? And I was always frustrated because I thought designers were spending too much time, drawing pictures of things. Sorry. Like, why draw a picture of something when it's ultimately going to change shape or size or whatever, right? Like, we're not laying out publications anymore. We're creating something more than that, and stuff I love to do, interactions, flows, and all that good stuff. So I was always seeing this in the horizon, but like you said, now that it's hit, the need for a lot of these people thinking and drawing, unfortunately, is being thrown out, right? Like, we don't need them anymore, because remember the good old days of programmers? They would solve a problem and they'd have the jankiest looking, sorry, Linux, but whatever. Like, it was functional, and that's really was the goal. It never was meant to be aesthetic or holistically whatever. It's just, hey, it gets the job done. And I don't have the time or effort or skill to make it like usable for another person. Let's put it that way. It works for me. And to me, I hope, and to this for our viewers, I always thought like, well, if designers can start coding more,
Mm.
right, which
And
is
now they
good.
can.
And well, I'd hope. No, I'm saying don't give up your design because your point
Mm.
of view is still what's valuable. And does it mean coders should start designing? Sure. And then therefore we do get rid of a silo that maybe was always artificial, right?
Yeah.
I think I've joked more than once of like, what's the deal with finance? Like, it's not like you are separate. You are in the engine of everything, but yet you get to go hide. You get to sort of go and be isolated in your zone, and you are not ever considered redundant. Because oh yeah, you control the money. Forgot. We just go and do the stuff.
Mm.
So hey, let's put this back on SpaceX. Obviously, they spend money. Apparently, their only profits are minimal, right? Like they don't make any money putting rockets into space.
Yeah, I mean, it's probably, I mean, the valuation is based on the future, right? The valuation is not based on, what's happening today. So they have demonstrated that they can, send to space reliably smaller rockets. Those are the Falcons. They can demonstrate it that they can land them, right? So now the extrapolation is, hey, they have much bigger rockets, and the expectation is that they will be able to pull that off. And by the way, I think so too, as well. So if there is, like 100-ton capability to LEO, right, to low Earth orbit, that is fully reusable stuff. So basically, you are just paying for the cost of the fuel, theoretically, right? So let's say you see those huge rockets, and then the cost of the fuel is going to be only $1 million, right? And everything is reusable, then yeah, maybe $1 trillion is legit, right? Because you can do space exploration now, right? Everything is easy once you are in low Earth orbit, right? There's this saying, no. So once you get there, then it's easier to kind of get everywhere else. So yeah, and then there is also, they are connected to Grok. And the news from last week, I think, was that everybody from Grok is going to Anthropic now. So Grok may not be like a standalone kind of type of a model. Maybe they will have a deal with Anthropic that Grok is going to be actually be Claude, but it's going to be using the supercomputer centers that Elon will build, right? So it's all kind of going to amplify each other, right? Like, hey, Elon's got the computational power, Anthropic's got the smarts to build the better and best models out there, right? So there is a synergy there. So even though IPO is SpaceX, they are amplified by the presence of Anthropic, kind of like understood that they're going to be kind of like close, right? So this is all kind of pretty crazy stuff that we are looking at, but it's all leads. I think the bet again, is that, hey, we need to kind of build better models, right?
Hmm.
So it used to be that the training of the model was kind of like the compute necessary was much bigger than the usage, like public usage, right? Now it's kind of the reverse. So they are kind of optimizing those things, but still betting on bigger and bigger and better models that require more and more compute, up until maybe certain kind of point. But yeah, kind of makes me remember the novel by Vernon Winch, the Fire upon the Deep,
Cool.
where
Sounds good.
they kind of find this kind of artifact somewhere buried very deep, and it's kind of like a quantum memory chip, basically. And they kind of, maybe kind of just, move it a little bit, or kind of like scan it a little bit, and what was in there was basically, yeah, I don't want to sell, I don't want to kind of spoil the whole book, but uh,
Spoiler.
yeah, but the spoiler alert is basically that there was some really bad AI, in that quantum memory chip, right? That's kind of infected everything like right away. So yeah, so that's kind of like, if we kind of get to that kind of level, like there is gonna be super smart AI. So we're gonna iterate maybe for a couple more years on NVIDIA, traditional GPUs, right? And then, the quantum comes online, and we're gonna iterate a couple of years maybe on the quantum chips. Then the Werner Wenge scenario that is not very pretty, which is kind of like a runaway thing because, maybe it's difficult to look at the neural network on a traditional chip, but it's absolutely impossible to check, what's going on a quantum chip. That's going to be pretty bad. So, but maybe this will be all kind of like happy end, right? There's a bet going that way. Yeah.
Well, no, you brought up a bunch of good things, although I like the idea of quantum chips only because it's a quantum architecture, which is not useful at all. Sorry, to most things that we
Well,
think
yeah, it
computers
is.
do,
Yeah,
right? I mean,
yeah.
they're not meant to solve. Again, they're weird, and it's a different architecture, right? And that's always been the point, just as much as NVIDIA's uh, graphics engine suddenly was really good at multidimensional, uh, math, linear algebra or whatever. You know what I mean? Like it's this idea that you just so happen to have a problem where you have to compute a lot of things at once. That was the whole point. Whereas the von Neumann architecture is like, no, you put the memory here, you do the processor, and you put the thing back in the memory, and that's a computer,
Mm,
and don't ever change this because it won't work. And it still doesn't work, right? Like it still has to work that way. It just we have bigger memory buses, we have bigger word lengths or whatever, but that architecture isn't going anywhere.
yeah,
But I
yeah.
do love the idea of programming. We were just saying like, yeah, programming and computing will be affected. And I do think, what do we think? 5 years, you should have a different kind of computer, maybe something, phones do sort of become less launch pads. I
Yeah,
don't
I
know.
would love a different.
But we still
I would
talk on
love
the
a.
phone. I mean, didn't we invent these so we could talk on the phone? And I just saw an ad like, hey, we talk a lot on the phone. I'm like, I haven't spoken on the phone. I do get to speak to my good friend Jack over Zoom, but like, I don't take phone calls from people,
Yeah,
you know, because you text them, because you know what I mean? Like, it's just our modes of communication get sort of more, directed or more, you know.
yeah, yeah. I would love a different interface. I would love to have like a glasses that are really spectacular quality, and wouldn't mind to have a little cable dangling from my glasses if it was like a very very sharp screen that I can look at, and so that's basically the world where Greg Bear, for example, another writer that is kind of like near future sci-fi, mostly kind of maybe political sci-fi. He's in his world, everybody's who's wearing those glasses, that are also a phone, and they can have like a, basically total integration. So yeah, so I wouldn't mind that. And then, maybe instead of typing, maybe have, voice commands, that kind of thing would be pretty good, revolutionary change.
Oh, you're in the market for an Apple Vision Pro. You haven't tried one of those on?
Yeah, I mean, they are still clunky, right? So my son
Well,
is
but that's a
very
form
much into
factor.
this.
All the features are there. It's just how much are
Yeah,
you
yeah,
willing to put up
exactly.
with, right?
Yeah,
But I
yeah,
do
yeah,
agree, like, hey, our eyes are a better cursor. That's a great
yeah.
invention that they tapped into, right? That's a really good way to handle X, Y, and Z. And I know they handle text inputs, and I don't know what they do, but I remember trying them on. Have you tried one on?
Yeah, my son has, the previous generation of, one of the kind of close systems. I think it's
No, no,
Vertex
no.
or
You
something.
got to try an Apple
Yeah,
Vision Pro. It's
yeah,
very Apple, meaning
yeah,
it's it's different because they
yeah,
thought quite a bit about the interface, right? They thought
mm,
quite a bit about how that part worked, whereas I think people are willing to accept controllers and stuff. Where it's like, no, Apple won't accept a controller. Remember when they were like, I
mm,
don't, we have one button. That's all you get.
mm.
With no keyboard, we won't have one. It's that feeling of like, but to your point, that's what like quantum computers. Okay, here's the constraints. You can't do X, right? You can't solve normal problems.
Mm.
But, that's fun. Given that, it's good at some other things. I just think our general computing needs hopefully are, I don't know. And this is going back to the 5G internet. It's like, well, the great thing about this is I do believe that if you never built out this entire infrastructure or had AT&T come along and run fiber to your house, which most people didn't have, right?
Mm.
That you got a certain experience or got nothing, right? You get nothing. And even as we got into all these other communication networks, they're not fast enough. 5G, if you're trying to have as they say, a family all streaming and doing whatever we do to make these data centers worthwhile, yeah, you need pretty huge bandwidth. And I'm just shocked that somehow or another these little things just manage that. How they do it is mysterious. Obviously, it has to do with
Mm.
well, it has to do with a lot of things. But I always thought the phones were the things you needed. And it's like, no, the phones, no. But having it be the hub, so to
Mm.
speak. And whenever I go to Portugal, like that's what everybody has because no one built out a huge network of wires because those are
Mm.
terrible, right? They work, but they're really expensive.
Mm.
So maybe that's our wrapping up point. Are we just building something that's insanely expensive because we can, even if it really isn't the solution to any particular problem? And I'm going to put our odds at pretty good that we are building it out for nothing. Because I also kind of wonder, you've seen the movie Gravity, like you can only put so much stuff up in space. You know what I mean? It's a rough world up there if you're
Mm.
not careful.
Yeah,
Because
the
there's a lot of
Kessler
crap
symbol,
that, yeah,
Kessler syndrome, where things kind of collide, and that's a very very real possibility, right? I mean, there's so
sure,
much
yeah.
stuff. So if two satellites collide, there's going to be a cloud of debris, and then it's going to get another satellite, and it's going to just amplify into basically like a kind of like a Saturn ring style of a showdown.
Eh, Let's hope not. But the point being, do we, I'm really happy to go on a bike ride in a bit that was built over old railroad tracks, right? So we built out a railroad system like crazy, and there are a lot of insane, horrible people that profited on this on the backs of others, right? Like
Mm.
there's not a lot of virtue in building out massive railroads, but we did it. But sooner or later they become decrepit and they need maintenance. They don't last forever.
Mm.
But thankfully we don't need them, sort of, right? We don't need them, so we put a nice pavement over it and let people go out and have nice bike rides. And the thing is, I'm afraid of that never happening in space. Let's just pretend like we'll never get
Mm.
any usage out of this stuff. Humans won't, at least, right? Like we're kind of, do we get something out of GPS? Absolutely, but that is a government run system. That is not a for-profit system, which is good too, because then it's like, okay, you know, I don't know if you ever do GeoGuessr. Have you ever heard of this?
Mm.
GeoGuessr is a place where it drops you on Google Maps someplace on Earth, and you have to figure out where you are. It's really fun
Mm.
because you are somewhere, and maybe you'll see a sign, or maybe you'll recognize. Who knows? But it tends
Mm.
to drop you in the middle of nowhere because it used to just do urban areas, and now it does more stuff. But whenever you see things that are Arabic or Chinese or something like that, Google is not allowed into a lot of places on Earth. Let's just put it that way. So you can kind of guess where you are only because you know that Google only goes to these particular places. So the reason I bring this up is the tacit knowledge of these wide areas of ubiquitous things is
Mm.
going back. It's all going to be about interference. There's always going to be interference. Study interference. That's where you'll find, the real answers to all you
Yeah.
out there watching.
Yeah. Yeah. Absolutely.
Is that too prophetic to end our episode on? Anyway,
Yeah.
good to catch up, Jack. I missed you last week. We'll make sure to get this one out because people need to know. interference.
Yeah. Yeah, absolutely. And we need holodeck. I think, I would be happy to have a holodeck as an interface.
Well, I 100%. I'm sure you won't have to wait in line. You really should try out the Apple goggles. It does.
Mhm.
They have a very good demo.
Mhm.
And what the interesting part of the demo is, I don't know in regular things you don't have glass, like they have glasses built into it, by the way, just to let
Okay.
you know. Yeah,
Okay.
like you can't wear glasses. They
Mhm.
have to be built in because your eyes are the cursor. But
Mhm.
just getting used to that is the beginning of this demo. And then they take you on this road of doing all these things with it, and you start to learn how to use your eyes and actually your fingers. It notices what they're doing, and that's how you interface with the computer. So to me, I think it was a really spectacular, imaginative idea of what computers could be. Now the question is, do they have any AI? I don't remember any. Like that wasn't
Mhm.
what sold them. What sold them was that you change the architecture, and therefore the people using it change the architecture,
Mhm.
which may be our next topic. How's that? Like, are we ready for an architectural change?
Yeah. Yeah. That's a good one. Yeah. Yeah. I would be ready.
You are, of course you are. That's why that's why you're the can-do guy. You will do it.
Mm. Yeah. All right, Mike. Yeah. Thank you. That was good.
Always a pleasure. Cheers.
Yeah. Bye bye.